Hi everyone, I'm Andy. I'm the Power Systems lead at Farad Ai, and we'll be giving a short overview of the platform that we've developed through the MEDApps competition, case study for customers, and then a live demo at the end, and happy to take any questions. So quickly, the agenda for today, I'm going to give a quick introduction on Farad Ai, what we do, who we are. I'm then going to go through the case study for customers and finish off with a demo of our product Compass. So net zero, I think, as everyone realizes here, is expensive, uncertain, and for the moment, mostly government driven. We know that it's a very expensive problem to solve, estimated $9.2 trillion of annual capital spending needed to reach net zero by 2050. We know that 4 out of 10 businesses feel as though they're overwhelmed and don't think they'll reach these net zero targets at the moment. And we know that governments are the driving force, but only 22 countries have declared themselves as net zero or put it into law. So this is a really big problem for the UK and for the world. And in the UK, one of the biggest problems of the net zero transition is electrification. So this is the major driver to fight climate change, but it is very challenging with the grid infrastructure where it is at the moment. The pain points really in the electricity network are that the grid is very hard to decarbonize. So as we develop new technologies to plug into the grid, the way that we're generating our electricity is fundamentally changing. We're going from this top-down approach where everything is generated at the transmission network and filtered down to people's homes to this very distributed, decentralized way of generating, storing, and distributing energy. And that could overload the grid network in its current form. It was a grid that wasn't designed to work that way. One of the other major problems that MEDApps is addressing is that the data are really inaccessible. So for a long time, grid data was very secretive. It wasn't something that most people could get access to. And this was a big blocker for innovation that through the MEDA and MEDApps competition, a lot of work has been done to overcome that barrier. And one of the final big problems to electrification is that actually in some places the data aren't even available. They're not even there. So fewer than 5% of low voltage substations are metered and actively monitored. That lack of metering on that last mile of the network is a big challenge that the country and the world really needs to solve if electrification and decarbonisation is going to work. And that's really the suite of problems that Farad Ai is looking to solve. So we're targeting those pain points in the electricity network as decarbonisation happens. And we're doing that by combining lots of different data sets from different sectors. So the platform in its current form has well over 100 million data points now across about 60 independent data sets that cover 6 core fields from the power systems engineering to socioeconomics, planning legislation, and traffic flow modeling. And using that, we have created a software as a service product called Compass that can be used by EV developers to find the optimal location for EV charging infrastructure. It can be used by renewable energy developers to find optimal locations for their developments. And it can also be used by network operators to find potential constraints in the grid and plan for future upgrades. And by doing this, we're really looking to level up the power network. So the power systems analytics that we've developed works across all tiers of the network. We model the shift of power flows from the transmission through the distribution to that low voltage network. And we can do that using that, we can identify bottlenecks, predict availability anywhere through the grid hierarchy. That low voltage end of the network, we're basically filling in the gaps using machine learning to about 70% accuracy is what we've got so far. And yeah, so using that, we're sort of building up a holistic picture of the grid, taking a whole systems approach that combines power systems, graph theory, and machine learning to create this kind of whole systems picture of what the grid is doing and where the constraints might be. And this has all been folded into Compass, which is a market-ready product that uses the combination of data sets that I mentioned earlier, so land use, traffic flow modeling, grid data, socioeconomics, to create an accurate heat map of peak demand at that low voltage last mile of the network, and that we can use as a baseline to simulate future scenarios in the power system, such as predicting the second order consequences of this new technology that's being built and connected to the network. So the next section is a quick case study for a customer that we've got at the moment, and the value proposition to them, and where they consider this to have been most, using Compass to have been most effective for them. So the three key target markets for our platform are EV charge point developers, so major oil and gas companies or dedicated EV infrastructure developers, for them to find the optimal locations for their EV stations. We're also targeting renewable energy developers and grid operators for site selection, site optimization, and congestion forecasts. And finally, we're also targeting city councils and local government for kind of the local area planning that they undergo, and to find the optimal locations for these kind of low voltage curbside EV chargers. And I think really the major benefit that we've seen from working with our various customers is that the grid capacity is incredibly fast paced. Securing grid access is highly competitive. Over 30% of substations are constrained. So that sort of echoes what advanced infrastructure was saying earlier, that around a third of connections just aren't really suitable. We know that over 1 gigawatt of new connections contracts are secured in the UK every single month. And we also know that over 100 megawatts of old contracts are being disconnected every single month. And this is sort of a very fast-paced, rapidly moving and rapidly shifting market. So getting that extra insight at the moment that the data becomes available is incredibly valuable for developers looking to connect to the distribution level of the network. And that kind of urgency of obtaining grid connection is where the most value for us that we can provide is. And this is sort of summarized here on this slide. So the customer that we were working with basically previously, before they contacted us, needed to maintain and request data and follow-up messages from all 6 network operators. They then need to look through and clean all of the data and do all of the data processing to identify the locations that they were looking to develop on. And then there is a lengthy and costly process to understand the grid capacity that's available. So for our customer in particular, they had around a 30 to 40% success rate for their grid connection applications. And this really presents them a huge risk, because if they can't secure the connections, they can't build the developments to sustain their business, to sustain their growth. And through access to Compass, through access to the Farad Ai platform, we have effectively taken a huge chunk of work off of their hands. So they've saved around 2,000 engineering hours per annum. Their success rate to connect to the grid has gone up to 85%. And this has in turn allowed them to accelerate the process of securing grid, accelerate their growth, and estimating up to £186,000 per annum of additional revenue. And I think the next stage is going over to the Compass product demo. So if I exit out of here and go over to the next tab. So this is the live demo of the platform. So I guess case study here is that somebody has come to us and said, in the central Bristol area, where is their space, where is their capacity for me to build a 1 megawatt EV charging station that needs 100 square meters of space, and where are the likely locations that I'm going to get planning permission for that development. And our platform has looked through all of the data sets that we have in the back end and selected 5 potential sites here that you could connect to. We can overlay some of the layers now that show why we've chosen these sites. So we've got these low voltage substations, medium, high, and national grid substations. So there's a couple of low voltage substations here. You can see a medium voltage substation out here. If I keep zooming, there's the national grid substation is, so high voltage up there, and national grid substation is somewhere, but quite far away. So if I zoom in now again, we can also see where are the existing EV charge points on the map. So these then show where's the existing infrastructure, and we're already starting to see here some validation of the platform that site 1 actually already does have EV charging infrastructure inside it. Site 4 has EV charging infrastructure very nearby. So we're starting to see some validation that these locations are good locations for EV charging infrastructure. We've also got flood zone data sets. So this might affect, I think, less so for the EV charging sectors, but for renewable energy developers, where you might be able to build your renewable energy sites will be restricted by where are their flood zones. It'll also be restricted by the protected areas and the protected buildings. So these are all the listed buildings in the UK. We have a land use tab as well. So this takes data sets on what land is being used for and matches it up to the land registry, the HM land registry data set, to create a sort of SimCity style map of land use in the local area. We have all of the major transport links and how you would access them or how you would potentially get to them. So from site 1 here, you'd track through to this major road network. And then one of the things that we've developed recently is the ability to predict demand at the low voltage end of the network. So what the platform is doing now is essentially looking at all of the buildings in this area and calculating a demand profile for those buildings, and generating from that a heat map of the local area where we think demand is most kind of densely located. So the darker the color, basically the higher demand. So we're seeing this kind of highly commercial area is very high demand. And then as you go out to the more residential or more park-based areas, the demand drops off. For each of these kind of different data layers, we also have a little bit more in-depth analysis that can be done. So at the low voltage end of the network, we are able to predict a connection probability. And then up through the higher voltage end of the network, we can actually predict the exact demand headroom that would be available. So Clifton would be the substation to connect to here. St. Paul's, we're looking at highly constrained substation. And then up through the high voltage network as well. So you can see that there is capacity available at the high voltage end. And by doing that, you track not only where are the constraints in the network at the level that you want to connect to, but also at all of the levels above it. So you will get an understanding of where might the reinforcement work need to take place, how much that reinforcement cost is going to be tracked up through the network. We also offer some predictions of EV charging utilization rate. So we're predicting based essentially on hotspots in traffic in the local area, what we expect the uptake of EV to be based on traffic in the local area as well as local competition. And finally, we have the land use layer that I showed earlier, aggregated now into this land use tab that tells you both what the current use of the site is. So this site 1 is currently being used as public car parking, and also the breakdown of land use within a kilometre radius of the area. And the idea here is to provide users with a comprehensive and accurate stream of data that can inform decision-making processes and make sure that, yeah, their decision-making is data-driven as we venture into net zero. And that's it from me. If anyone has any questions, happy to take them.
Great presentation. Thank you, Andy. Great demo. We have a couple of questions in the chat. The first one is, you mentioned that the grid is changing at a very fast pace. So how do you get up to date grid data? So how do you ensure that data you receive is up to date?
So that changes from network operator to network operator. So some of the network operators, in fact, most of the network operators now will release monthly updates. And for basically where there are gaps in the data, it's sort of, I guess, the same answer that advanced infrastructure gave earlier. It's without being flippant, we fill the gaps in. Yeah, so we have developed in-house effectively ways to forecast and predict headroom capacity and demand that we can use to fill in the gaps where the data sets aren't available, and then where the data sets are available, we will get them in on a monthly basis.
Right. And what level of detail does your tool go down to? So for instance, can you see constrained cables or feeders from buildings? Or is it primarily substation constraints?
So it is, so what I showed in the demo is available nationwide for all customers. There are some customers who would be able to access more detailed data, depending on the data sharing agreements that we have in place. So we can see constrained cables. That is something that we do offer, but that is for specific customers who basically we're allowed to share that data with. So it's the data sharing agreements that limit our ability to show that at the moment. So the substation constraints are what you get everywhere for everyone. And then the more detailed stuff is available kind of from different DNOs to different levels, and for different customers to different levels as well.
And can you tell us more or less what type of coverage do you have of data from distribution network operators in terms,
Yeah, so we have around 60% of the UK now. So we've got, three of the 6 DNOs. We've got that data from at the kind of LV and HV level.
So you can see also the feeders actually.
Yeah.
So you can see you have coverage of 60% of Great Britain.
Yeah, so it's three of the 6 DNOs. I think it's about 60% of the UK.
That's impressive still. That level of granularity is impressive indeed. And now you also mentioned that you calculate the low voltage demand. So can you tell us a bit more about how you actually calculate it? How you create that heat map that you showed us?
Yeah, sure. Yeah, so that heat map is looking at essentially a range of data sets on the individual building level. So combining things like EPC rating, EPC data, and classification data, so what the building is actually used for, as well as land registry title size. And by combining all of those data sets together, we are able to effectively train models that aggregate data at the substation level, compare that to the demand that is measured at the substation level. So it's using measured demand data from some of the network operators at the low voltage end of the network. So we can say, oh, this substation has this demand at this time. It's connected to these buildings. These buildings have this EPC, this land use, XYZ. And from that, you can build up a model that is able to predict more generalized kind of aggregate low voltage demand throughout the rest of the UK.
I see. And what is the granularity from a time perspective of these profiles? Is it monthly, daily, half hourly?
So what we have deployed at the moment is peak demand over the course of a year. So you get that just, what is the peak demand over the course of a year? What we are working on at the moment is to bring that granularity down to, we're hoping 5-minute intervals within the next couple of months.
All right, 5 minutes intervals. Right.
Yeah. So that's the data. We have some time series data at 5-minute intervals that is what we're using to train those models.
That's impressive. And all right. And also you mentioned that your tool can calculate or estimate the connection cost.
Yes. Yeah.
To which level of detail can you do that?
So that's another feature that we're currently building into the platform and iterating on and constantly improving. At the moment, it's based on substation constraints and estimating the reinforcement work that is required at the substation level if there is not a connection available, and then saying, well, this is the reinforcement work you need at these substations. This is how much that is estimated to cost. But we are, again, in the process of expanding that to the whole infrastructure development of whether or not it's a soft dig or a hard dig, whether or not any of the feeders will need to be, existing feeders would need to be upgraded, or existing circuits rather would need to be upgraded. What is the cost of you actually building the kind of lines to the connection point? So at the moment, it's just that substation reinforcement cost. And then we're looking at expanding that further in the next phase, basically, of development.
Yeah, given the time you had available for this tool, it's already quite, to develop this tool is already quite impressive. I guess the user can already have a good overview of where an optimal site might be, just simply comparing those costs. So that's great to hear. And another question that I would like to ask you, that is something I already asked to the previous speaker, especially in particular advanced infrastructure, is you're mixing open, shared, and proprietary data. I guess you have encountered some challenges in tracking license compliance. You have briefly mentioned that already in your answers, but do you have any suggestions on how these challenges can be overcome when someone is mixing different data sources? Because I guess on the call, there are people who are working on similar applications or having encountered similar problems. So it would be good to hear how you have approached this challenge.
Yeah, so I think for us, the approach that we've taken that I think has worked, or we feel has worked quite well for us, is, regardless of what data you're mixing, there is going to be a minimum viable product almost of data that you are allowed to share with everybody. And identifying that is the crucial first step. Because if you can say, well, these are the data sets and the data that everybody can access, then you can build something on that grounds that is universally accessible, and then you can sort of basically forget about data compliance because you know that everybody is allowed to access that data, and then you can build on top of that for individual users. So maybe the low voltage cabling network operator might not allow you to display to everybody, but they would allow you to display to a local council. kind of thing. So you can then build features, additional features that show additional data sets for particular customers. And then from that point, it's just kind of a permissions list almost for your users. So everybody has a base load of permissions, and then different users will have different levels of permission to different data sets based on who they are, and what access they get.
Right. So similarly to the answer, the previous speaker is like access control is the key.
Yeah, access control, I think, is the way that's worked for us.
Right. And did you have any challenge in terms of interoperability of licenses when combining data from different sources?
Yeah, so I think this is something that the energy sector, or one of the outputs of the MEDApps competition, is a kind of big learning point, I guess, for the energy sector, is that data interoperability isn't quite there yet. In a lot of the other sectors that we pull data sets from, they are interoperable nationwide. There is nationwide interoperability of the data sets there, whether that's kind of Ordnance Survey releasing their UPRNs that you can use to connect to the EPC data sets, for example, or again, Ordnance Survey with these UPRNs connecting to streets and unique street reference numbers. The interoperability is there, but it's not quite there yet for the energy sector. And so it is a big task for us to ensure interoperability. You can do it. You can go through and you can clean the data sets and make sure that they and put them in a format that is interoperable. And that's one of the first things that we did throughout the development and throughout the competition, is to define an interoperable format for grid data. But it's us defining it, and it's us cleaning the data to get it there. And that's something that is quite unique, I think, to the energy sector. In most cases, it's the energy supplier who ensures the data supplier, sorry, that ensures interoperability with other data sets.
Yeah, no, I totally agree. Have you found this issue in terms of interoperability also for the data licenses, when you're combining?
Yeah,
not only on the formats, sorry, but also on the licenses that apply.
Yeah, we have. Yeah. So there have been some data sets that we'll get one data set from one network operator, we'll get the same data set from a different network operator, but what we're allowed to do and who we're allowed to display those data sets to will be different. And I think that's one of the things that the kind of data sharing best practice that I think will come into force April next year is going to be hugely helpful for us, and I think other innovators as well, in having that kind of presumed open access to grid data.
Right. Well, thank you, Andy. Again, if anyone has any question for Farad Ai or wants to get in touch with them, I guess, well, they're quite easy to find. And yeah, we are at the end of this event. Thank you to all the attendees. And please keep engaging with these projects. And we will have also another competition coming that is starting now. This is called Open Digital Solutions. So please follow our events and our LinkedIn page, when you will be able to also hear from other very interesting projects and innovators. So thank you, everyone.